Ladies and gentlemen, we're going to review for the first half of quiz 4.1. It's actually not 4.1 to 4.7. It's 4.1 comma 4.7, right? It's only two sections, only 4.1 and 4.7. Here we go. Which of these following equations represents this parabola above? And it says check all that apply, all right? Select all that apply. So we have some in vertex form, we have some in standard form, and we need to see which one it is. So let's begin with the easiest form, which is vertex form, okay? So we know that our h value is 3, our k value is -1, and we know that the a value, let's check and see if the a value is 1 by verifying the pattern 1, 1, 2, 4, 3, 9. So if I am at this vertex, if I go 1 over and 1 up, am I on the parabola? Yes, I am. If I go back to the vertex and go 2 over, 1, 2, and 4 up, 1, 2, 3, 4, yes, I am. And last but not least, go back to the vertex and do 3, 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, yes, I am. So this is definitely the a value of 1. So we know our a is 1, we know our h is 3, and our k is -1. So we can now write our equation in vertex form. And what is vertex form? It's y equals a, open parenthesis, x minus h, close parenthesis, squared, plus k. So we know the a, h, and the k, so let's just plug it in. Y equals 1, which is really unnecessary. You don't even need to write it. X minus 3, close parenthesis, squared, plus k, plus -1. So you know, I don't even need a plus -1. I could just put -1. Right, -1, there you go. Now this is the equation, and of course you don't need the 1, so we could just rewrite it as this, x minus 3 squared minus 1. That's your equation in vertex form. Let's see if we could identify that one somewhere down here. That is right here. This one's it, okay? So the question is are one of these standard forms also the same equation? Now there's two ways of approaching this. One way, which we've been practicing, would be to find the vertex of each of these, right? So you could use the vertex formula. So you could take this first one and use the vertex formula, x equals -b over 2a. Of course, you're going to plug it in with parentheses, and once you get your answer, you could take that answer and plug it into your original quadratic trinomial equation to find your y value. And then you could verify if that vertex that you find is 3, -1. And if it's not, then you do the same thing over here. Use the formula, use parentheses. Once you get your x value answer, plug it into the x's, do the math, and see if you get the y value of -1, right? Assuming that you get the x value of 3. That's one way of doing it. Or another way of doing it, since you already know this equation, all right, since you already know that equation, I'm going to rewrite it, y equals, parenthesis, x minus 3 squared minus 1. And this is technically changing vertex form to standard form. It's pretty easy to do. All you got to do is be able to distribute and combine like terms using Algebra 1 skills. You see, right here you have a binomial squared, and when you have something squared, what it really means is for you to multiply it with itself 2 times. So x minus 3 in parentheses squared really means x minus 3 times x minus 3, and of course you still have the -1 over here. So how do you do this? You distribute one term at a time. So x times x is x squared, x times -3 is -3x, and then you take the -3 and multiply it by x. That's another -3x. Take the -3, multiply it by -3. That'll be a +9, and don't forget about the -1 that's out here. So now, after distributing, you need to combine like terms. As you could see, the -3 and the -3 will become a -6. Of course, we're talking about x's. If you owe $3 and you owe $3, you're going to owe $6. The x squared in the front just comes down because there are no other x squares to combine it with. And then the 9, take away 1, that will be 8. So you have a +8. Ladies and gentlemen, here is, all you got to do is bring down that y. Here is your quadratic trinomial equation in standard form. Y equals x squared minus 6x plus 8. And as you can see, that is this guy over here. So those are the two answers that you need to select to get this question correct. This one's nice and easy. What would the a value be of this quadratic function? Well, all you got to do is verify what the pattern is. Of course, if the a value is 1, you'll have the pattern 1, 1, 2, 4, 3, 9. And if you're at the vertex and you go 1 over 1 up, you will end up right there at that dot. If you go back to the vertex, go 2 over 1, 2, 3, 4 up, you will end up right at that dot. And go back to the vertex, 3 over 1, 2, 3, 9 up, 1, 2, 3, 4, 5, 6, 7, 8, 9, you will end up right at that dot. So we know the a value is 1. And if you're looking for it, 4, 2, negative 3, negative 1, that would be none of these. That's your correct answer for this one. Select all true statements of the above quadratic function. I love these because we have a quadratic trinomial equation, and we're going to state everything about the parabola without even graphing it, all right? As you can see, one option is the vertex, and that's how you should always start all parabolas when graphing. Find the vertex, okay? So let's find the vertex, which is going to be a coordinate, an x and y value, and we should all know that the vertex formula is x equals negative b over 2 times a, and when you use the formula, please use parentheses, negative parentheses over 2 times parentheses. So what is the b value? The b value is 4, the a value is negative 2, the c value is negative 3, but we don't really care about the c value unless we're talking about the y-intercept value. But anyway, the formula only needs b's and a's, so let's plug in a 4 right here, a negative 2 down here, and what do we end up with? We end up with a negative 4 up on top over a negative 4 on the bottom. That will give me a positive 1. So the x value is positive 1. The x value of our vertex is positive 1. Let's now find the y value simply by taking the x value of 1 and putting it where the x's are at, right there, and working it out. So what I'm going to do is I'm going to rewrite this f of x function, this quadratic trinomial equation. And of course, I put parentheses instead of the x's, right? Put parentheses. Why? Because I'm going to plug in the 1 right in there, which technically I'm going to put in those parentheses. So let me put that 1 right in there. Boom, boom. And let's do the math here. I'm going to do some math in my head. What is 1 squared? You always start with parentheses, but there's nothing to do in parentheses. You move on to exponents. What is 1 squared? It's just 1. So this is just the number 1 times negative 2. Negative 2 times 1 is negative 2. What is 4 times 1? That's just 4. And bring down the minus 3. And there you go. What is negative 2 plus 4? That's 2. 2 minus 3, that is negative 1. So this is our y value. Okay, so how do we find the y value? You plug in the x to get out the y. So our vertex, which we started up here, is 1, negative 1. And as you could see, the vertex is not negative 2, negative 19. All right, we have 1, negative 1 as a vertex, so that's definitely not it. Moving on to a next one. It says the range is less than or equal to negative 1. Well, range are your y values, right? And we got to actually think of visually what this parabola looks like, knowing that the vertex is at 1, negative 1, right? So again, 1 on the x, negative 1 on the y. Here's a vertex. Does it open up? Or does it open down? It opens down because it's negative, and it's kind of narrow because it got vertically stretched by 2. So it's opening down. This is just a sketch, all right? But anyway, if we know that it opens down, then this vertex is technically the maximum value, all right? That's the maximum value. What is the maximum value here? It's the y value of negative 1. Obviously, your vertex is negative 1. That's the highest point it reaches. So if you know that the maximum value is negative 1, you should know that the range are your y values that are less than or equal to that maximum value of negative 1, which is the y value of your vertex. So range for sure is less than or equal to negative 1. That's a true statement. Now, the next one says the minimum value is negative 1. That's false. We know it's opening down, which means that from left to right, it's going up, 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 up. It reaches a maximum height, then it comes back down. Okay, so we know that that's false. This should have said max, right? But it doesn't. It says min, so you're not going to select that one. What else? The first transformation from the parent graph to the current graph is that it gets reflected over the x-axis. Yep, if you have a negative sign, the first transformation that happens if you're describing transformations is that it gets reflected over the x-axis. It opens down, right? So this is absolutely correct as well. And it says the axis of symmetry is the equation x equals 1. And we know that the axis of symmetry will always be x equals negative b over 2a, or simply x equals the x value of the vertex, which in this case is 1, right? X equals 1, so that's absolutely true as well. You select those three, hit enter, and you will get full credit on this question. Next question, another one of these where it would be good to just go through and state as much as you can, right? Let's begin by finding the vertex, which is a coordinate, x and y value. How do you find the vertex? You use x equals negative b over 2 times a. When I use this formula, I always, actually any formula, I usually put parentheses instead of the variables when I plug in the values. So the a value is negative 1, the b value is 6, the c value really don't care about in this situation, unless we're talking about the y-intercept. Then the y-intercept's always this last number, when it's in standard form, not vertex form. Anyways, I'm off to a tangent there. Sorry about that. Let's move back to finding the vertex using the vertex formula. The b value is 6. Put a 6 right there in place of the b. The a value is negative 1. So what do we have here? We have x equaling negative 6 over negative 2, which means x equals positive 3. So we know that the x value is positive 3. We now need the y value. So let's just rewrite this quadratic trinomial function, but with parentheses instead of these x's. And the 3 comes into those parentheses, right? All I did was take the x value of 3 and put them where the x's used to be at. And now let's do the math. Once again, we're going to use PEMDAS. Parentheses is the first thing to look at, but obviously there's just a nice, beautiful natural number 3 in there. After that, you move on to e exponents, right? Now, a lot of students make the mistake and think, oh, negative 3 squared is positive 9. Wrong, okay? This negative sign is kind of like the multiplication of negative 1, but you have to deal with the exponents before multiplication. So always do the exponent first. That is 3 to the second power with the negative sign in front. So 3 to the second power, 3 times 3 is 9. Put that negative sign in front, you just bring it down, right? And then over here you have 6 times 3, that's positive 18. And then we have the minus 15 at the very end. So going from left to right, what do we have here? Our answer, negative 9 plus 18, that's positive 9. Positive 9 minus 15, that is negative 6. So our vertex y value, the y value equals negative 6. So we know our vertex, and the first statement, it says that the vertex is 3, 11. Well, the 3 was nice, but the 11's wrong, so don't pick that one. That's incorrect. It says the range, okay, the range is y is less than or equal to 11. And we know that the vertex is the most important point because the vertex has the axis of symmetry, x equals 3, and it also has the range. It either opens up or down with this y value, okay? So this is opening down. So just to get a visual, let's do a quick sketch. You might have this sketch already in your head. If you go 3 to the right, go to the coordinate 3, negative 6, you're going to end up somewhere down here, okay? And this thing does open down because the a value is negative. So if it opens down, then technically you reach a maximum height of whatever that y value of your vertex is, and then it goes down forever, okay? So the range is definitely not greater than, but it's less than this certain y value, the y value of your vertex. So the range is y is less than or equal to negative 6. That's your range. And this is not it. This is the range is less than or equal to 11. That's wrong. So far both statements have been wrong. Let's go with this one. The axis of symmetry is x equals negative 3. Maybe I shouldn't have circled it because it's not right. This one right here, it says the axis of symmetry is x equals negative 3. This is positive 3. So we know that the axis of symmetry is not negative 3. It should be the axis of symmetry should be x equals positive 3, not negative 3. What the heck? So far everything's been wrong. How about this? It says the max value is negative 6. Going back to our most important point, that vertex at 3, negative 6, is this a maximum value at negative 6? Yes, it is, because it's going up on the y's, up on the y's, up on the y's, reaches the max value, that vertex y value of negative 6, and then it goes down. We know that from the range, right? Y is less than or equal to negative 6. So the maximum value really is at negative 6. That's definitely a true statement. Make sure you select that. This last one, it says a transformation from the parent graph is a reflection across the x-axis, definitely, the a value is negative, and also shifts 3 to the left and 6 down. Well, you can't see an h and k up here, but you do know that your vertex is the h and k, so these are your shifts. Obviously, to get to your vertex from the origin, you shifted 3 to the left and 6 down. And that's exactly what it says here, shifts 3 to the left and 6 down. So this one is also true. Ladies and gentlemen, don't expect always to find 2 true statements. Maybe all of them are going to be true statements on the actual test. Maybe none of them are true statements. Maybe only one of them is true. Maybe only, I don't know. Well, you guys get the idea. Let's move on. Select all the true statements of the above quadratic function. Again, let's begin with finding the vertex. The vertex is the most important point. How do we find that vertex? We use the formula x equals negative b over 2 times a. When you use it, please use parentheses instead of those variables. Of course, the a value is 1 in this case, right? The b value is negative 10, and the c value we don't really care about unless we're talking about the y-intercepts. Anyway, let's find that x value of the vertex by plugging in the b value of negative 10 inside of the parentheses and the a value of 1 down there. So when we have a minus 10, we really have a plus 10. 2 times 1 is 2. So we should know that the x value is 10 divided by 2, which is 5. So the x value of our vertex is 5. Anytime you have an x and you want the y, simply plug in your x into the x's, do the math, and it'll say y equals whatever your answer is, and you'll have the y value of your vertex. So let's rewrite that standard form quadratic trinomial, x squared minus 10x plus 5, and let's plug in the x value of 5 into those parentheses, and let's do the math. Exponents first, that's 25. 10 times 5, that's 50. Of course, we have this minus sign in front and the plus 5 at the end. Going from left to right, 25 take away 50, that's negative 25. Plus 5, the answer is negative 20. And what did we just find here? We found the y value. Okay, so the y value is negative 20. So the vertex, the most important point of this parabola that opens up, that has a pattern 1, 1, 2, 4, 3, 9, because the a value is 1, is 5, negative 20. The vertex, man, on all of these, the vertex have been wrong, right? That's sad. Anyway, yes, this is incorrect. The vertex we know is 5, negative 20, not negative 580. The axis of symmetry is x equals the x value of 5. That's definitely wrong because it's not the x value of 5. It's saying that the y value is negative 5, which that's just really, really wrong. Even if it said x equals negative 5, that would still be wrong, so that's incorrect. The transformation from the parent graph to the current f of x graph is that it shifts 5 to the right and 20 units down. Well, since it's not in vertex form, you can't see h and k, which are your shifts, so you got to find your h and k from here. And that makes total sense. From the origin, you have to go 5 to the right on the x-axis and 20 down. So 5 to the right and 20 down, that is absolutely correct. That's one right answer. Another one that we need, the last one we need to check, the minimum value is negative 20. Well, in order for it to be a minimum value, it has to open up. And we know that this does open up, and that's how you get the minimum value, and it is at the coordinate 5, negative 20. So if we were to 5, negative 20, that would be way down here somewhere, and it is opening up, right? So the minimum value is at negative 20. That's absolutely right. 5, negative 20, that's the lowest point. From left to right, I mean, up here it'll be in the positives. It's going to go lower, 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 till it reaches a minimum value of y at negative 20, and then it comes back up, and y is 1, 2, 3, 4, 5, and it keeps going up forever. So this is a true statement right here. The minimum value is negative 20. Which quadratic function represents the graph above? Well, if we have the h and the k, which we do, we know that h is 3 and k is negative 1. And could we find out the a value? Well, if your a value equals 1, you'll have the pattern 1, 1, 2, 4, 3, 9. And if it's not, then you got to modify that pattern and you'll have your different a value. So if you're at the vertex and you go 1 over 1 up, you'll be at the 1, 1. 1, 1, you will be at the coordinate. if you go back to the vertex and try 2, 4, 2 over 1, 2, 3, 4 up, yep, it works, right? Let me put red dots here. Here's the vertex, 1, 1 would be right there, 2 over 4 up would be right there. And if you do go back to the vertex and go 3 over and 9 up, you'll be up there. It doesn't matter which way you go, it'll still be like if you want 1 over 1 up this way, or 2 over 4 up this way, 3 over 9 up this way, it's the same deal. So we did verify that the A value is 1. So since we have a vertex form equation, let's write our equation in vertex form. So we have y equals A, absolute, or not absolute value, I'm saying parentheses x minus h, close parentheses squared plus k. And we know the A, the H, and the K. So we really have y equals 1, but I'm not going to put 1 because, I mean, A equals 1, yes, but I'm not going to put the 1 because it's pointless, right? You don't need a 1. X minus H, what is H? H is 3, close parenthesis, squared, plus K. K is negative 1, okay? Which we don't even need the plus negative 1. We could just write it as minus 1, okay? So there is our vertex form quadratic equation. And this is not it, right? This says a plus, it should be a minus. Okay, so this is not it. Do not pick that one, okay? We know that this is it. We know that this guy right here is it. Wow, I scratched it out. Sorry about that. But the rest of these are in standard form quadratic trinomials, ax squared plus bx plus c, ax squared plus bx plus c. And we need to see which one it is. So you could, there's 3 of them here. This would take a while to do negative b over 2 times a to find the x value of the vertex, and then you take that x value and plug them back into the x's and do all that math to verify that the y value will be negative 1, right? It takes a long time. So what I recommend is for you to focus in on this equation that you know to be true. And I'm sorry for scratching that out, but here's the equation, y equals x minus 3 squared minus 1. And let's actually do this algebra. Let's write this binomial of x minus 3 squared, write it x minus 3 times x minus 3, writing it 2 times. And then don't forget about the minus 1 that's at the very end. But we are going to distribute x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is another negative 3x. Negative 3 times negative 3 is positive 9. Bring down that minus 1, and you will have some combining like terms to do. We have a negative 3 and a negative 3. That's a negative 6x. We have the x squared in front. And 9 take away 1 is a positive 8. You have, well, technically y equals x squared minus 6x plus 8. So let's see if that's over here. And it is this equation right there, y equals x squared minus 6x plus 8. Final equation, or final problem here on this video is to select all true statements. Step 1 on graphing any parabola is to find the vertex. Absolutely, no question about that. Sometimes if it's in vertex form, it's easy, h and k. If it's in standard form, you actually have to use a vertex formula. What else? It says x equals negative b over 2a. I know that's a vertex formula for the x value, but it says is the axis of symmetry, which is absolutely true as well. Why is it true? Because if I know that this guy gives me the x value of my vertex, and I know that the axis of symmetry is simply x equals that number, that x value of the vertex, then this does give it to me. This is the axis of symmetry as well. What else? It says the a value of the quadratic function tells you how the parent graph gets shifted. That's false. The h and k, that causes the shift. The a is a vertical stretch or compression, right? So this is false. This is false. And the last one, the y-intercept of a standard form quadratic function will always be the c value. That is absolutely true. If you have y equals ax squared plus bx plus c, that c value is always your y-intercept value, okay? Because to find the y-intercept, you have to set x equal to 0, and if you put a 0 right there and right there, everything here becomes 0, and c is the only thing left. So on this question, we're supposed to identify which of the following quadratic equations represents this graph right here. Okay, so we know 2 types of quadratic equations. We know vertex form, which is y equals a parentheses x minus h close parentheses squared plus k. And we also know standard form. And standard form is easier. And standard form is y equals ax squared plus bx plus c, where your a, b, and c are just numbers, right? Anyway, when we look at these down here, they don't look like vertex form because they don't have parentheses around them. But if you wanted to, you could forcefully put parentheses around the x right there. Because there is no other x term. There is no bx term, right? If there were a bx term, like if there were a 5x in there, then you wouldn't be able to put parentheses around the x. But because none of these down here have a bx term, you could put parentheses around the x and you could visually see it as y equals 1 parenthesis x minus nothing squared plus 2, right? And you could see your vertex is 0, 2, h and k, 0, 2. And this obviously does not have the vertex at 0, 2. But that's not the best way to tackle this problem. The best way to tackle this problem is to identify your h and k, which we know is 0, 0, and also identify your a value, because if you have your a value and your h and your k, you could actually plug it all into vertex form and have your vertex form equation. So if the a value is 1, we know that the pattern would exist 1, 1, 2, 4, 3, 9. So from the vertex, if you do go 1 over and 1 down, will you be on the parabola? The answer is no. If you go 1 over and 2 down, that's when you'll be on the parabola. So it looks like the output got modified by 2 to get the pattern 1 over 2 down. Does that make sense? Now, if we go back to the vertex, assuming that you're modifying the a value by 2, then a value is not 1, maybe a value is 2. But if that's true, then this one should not be a 4, it should be an 8. So let's check the next part of the pattern, 2 over from the vertex, 8 down, and let's see if that's true. And apparently it is 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. That's perfectly on the parabola right there. So we know for a fact that the a value is 2 just by counting the pattern. It's not 1, 1, 2, 4, 3, 9. It's actually 1, 2, 2, 8. The pattern outputs got modified by 2. So if you know your a value of 2 and your h and your k, you'll be able to plug it all into vertex form. Now, the important thing about this is that it's opening down. So if it's opening down, we know that the a value has to be negative. So the a value, it's not just 2, it's actually negative 2. And the h is 0 and the k is 0. So if we plug it into vertex form, y equals a being negative 2, parentheses x minus h squared plus k, and you know that the h and k are 0 and 0, then you don't even need the plus 0. As a matter of fact, you don't even need the x minus 0. That should just be x squared, which means you don't even need the parentheses. It would just be y equals negative 2x squared. That is your equation that's represented on this graph right here. And if you look for that answer on your multiple choice on this part of the practice test, you'll see that it's not there. You have this one, but that's positive. So the correct answer here would be none of these. On this one right here, we have a standard form quadratic trinomial function, and they want us to rewrite the standard form equation in vertex form. Okay, so this is ax squared plus bx plus c, and they want us to rewrite it in vertex form, which is y equals a parentheses x minus h squared plus k. Whoops. So obviously the multiple choice answers are all in vertex form, but how could we verify, or how do we change this standard form to vertex form? Well, we know that vertex form has a vertex, hk. Are we able to find the vertex from here? The answer is yes, right? How do we find the vertex in a standard form equation? You have to use the vertex formula that we learned on this section. The vertex formula is x equals negative b over 2 times a. And that will give you just the x value of your vertex. Again, the vertex is the most important point. That's what you start with on any parabola, okay? Find the vertex. And this will give you the x value only, this formula right here. And when you use a formula, please replace the b and the a with parentheses. That way you don't make any mistakes. So when you look at your standard form quadratic trinomial, you have your a value of 5, your b value of negative 20, and your c value of negative 17. We don't even have a c value in the formula. So the c value, negative 17, we're not even going to use it. The c value we don't care about, but we do care if they were to ask us to find the y-intercept of your parabola. The y-intercept, you always set x equal to 0, which means that your c value will always be your y-intercept. I already know that this parabola that opens up, that got vertically stretched by 5, which means it's kind of narrow, I already know that it's going to cross the y-axis at negative 17, just by looking at it. But they're not even asking that on this question. They're asking us to rewrite it, so let's find the vertex because we need the vertex in order to write it in vertex form HK. So plugging in the b value of negative 20 and the a value of 5, a negative 20 becomes positive 20, and 2 times 5 is 10, which means that our vertex x value is 2. That's our vertex x value. So here's our x value of our vertex. That's the nice, beautiful number 2. If you have the x and you want the y, all you have to do is rewrite your entire quadratic trinomial equation, but put parentheses in place of x's. That way you could plug in that x value of 2 right into those x's. So let's do that. I'm going to rewrite it exactly the way it is. Y equals 5, parentheses squared, minus 20, parentheses minus 17. And we are plugging in the x value of 2 right there and right there. You could use a calculator on this part. Please don't make the mistake of not using the correct order of operations. PEMDAS is the correct order of operations. Parentheses first, but there's nothing to do inside the parentheses. You move on to e, exponents. So we do have 2 squared right there. 2 squared is 4. So what we really have here is 5 times 4. 5 times 4 is 20. Then you move on to the next one. You have 20 times 2, that's 40, with a minus sign right in front, so that's a minus 40. Then, of course, you just bring down that minus 17. So what we really have here is minus 20 minus 17, which gives us a negative 37 as the y value. Whoa. So now that we know the vertex, we technically know our h value is 2, our k value is negative 37, and we also know our a value. What is our a value? It's the same exact a value as your standard form, which is 5. So knowing a, h, and k, we will be able to write our vertex form equation. So we have y equals 5x minus 2, close parentheses squared, minus 37. And that is your vertex form equation. This is it right here. We have changed the original standard form quadratic to this new vertex form. Now I am not going to go up here because I didn't write the correct multiple choice answers, but I will fix it on the actual practice test. But this is the one that you should select.